Alright guys, now we're going to get onto non-right angle triangles. Whenever you see a question about angles or sides of a triangle, I always think of like a little flow chart in my head. I think, okay, this question is about triangles, alright? And then I think to myself, what kind of triangles are there? Well, there are right angle triangles and non-right angle triangles. If I have a right angle triangle, I can use Pythagoras, or I can use SOHCAHTOA. So is this triangle a right angle triangle? No. So straight away I'm like, boom, I'm not going to use Pythagoras, I'm not going to use SOHCAHTOA. So now there are two tools you can use to help you figure out non-right angle triangles. There's the sine rule and there's the cosine rule, okay? And we have to figure out which rule should we use, the sine rule or the cosine rule. Whenever I do questions with non-right angle triangles, I always check for the sine rule first. And the key word for the sine rule is pairs. Super nice, easy phrase. Think of the idea of pairs. What does pairs mean? If you have a non-right angle triangle, if you have this angle, let's say this is angle A, we like to give angles capital letters. Its pair will be the side opposite the angle, so this is A. If this is angle B, this is side B. If this is angle C, this is side C, okay? And you use the sine rule where you have two pairs, okay? Let's see if we can use the sine rule in this question here. So we use the sine rule if we have two pairs. Well, I know this pair. We call these the side angle pairs, by the way. And I want to find this pair, okay? Therefore, we're going to use the sine rule here because I know this pair and I want to find this pair here. So if you go into your formula sheet, the sine rule is A over sine A equals B over sine B equals C over sine C. So the first thing you want to do is first label your triangles with A's, B's, and C's. I like to call side A the side I'm trying to find. So I'm going to call this is A. Therefore, the angle A will be the angle opposite it. And then we can call this side B and then this angle B. And we don't really need C and sine C, so we'll ignore that. And we're just going to fill it out. So A is X, so X over sine A, so sine angle A, which is sine 38, equals B, which is 13, over sine B, 100. That's step one. Just fill out your sine rule. Step two is realize the goal of the question. We're trying to find X. So I want to isolate X. Well, if X is being divided by sine 38, to get rid of divide by sine 38, we're going to times both sides by sine 38. Times this side by sine 38, times this side by sine 38. So on the left-hand side, the divide and times sine 38 cancel out. So X is equal to, and we're just going to throw this onto our calculator. So 13 over sine 100. So all I did in my calculator was I did 13 divided by sine 100. I got the answer, and I multiplied the answer by sine 38. So X is equal to 8.12. And that's your answer, okay? So basically, the hardest part is knowing when to use the sine rule. We use the sine rule when we have a non-right angle triangle and we have two pairs. I know this pair, I want to find this pair. Ready? Let's do this question here. So I see a question, it's a non-right angle triangle, and I want to find side AB. So straight away, I'm like, okay, it's a non-right angle triangle, so I only have two options, the sine rule or the cosine rule. For the sine rule, I know I need two pairs. Well, I want to find this pair, this angle side pair. Do I have another pair? I don't know this full pair. Nor do I know this full pair. So it kind of looks like I can't use the sine rule. But you can. Sometimes you have to do an extra step. What do the angles in a triangle add up to? 180. Therefore, we can actually maybe find this angle. And if we're able to find this angle, perhaps we can use the sine rule. So to find that missing angle would be 180 minus 33 minus 62, which is 85. Okay, and now I want to find this pair here. And I know this side angle pair here. So we can use the sine rule. So here in this question, the sides have been labeled for us. So if this is angle C, we'll say this is side C. If this is side B, if this is angle B, this is side B. And this is angle A, this is side A here. So let's write it out. A over sine A equals B over sine B equals C over sine C. In this case, we know pair B, and we're looking for pair C. So we don't need the A's in this one. So we can just go ahead and fill it out. So little b is side B, which is 15, over sine B, which is sine 85, equals little c, which is x, over sine C. So angle C is 33. And we want to find x. Let's isolate x. Well, x is being divided by sine 33, so we'll times by sine 33 on both sides. So it's going to be 15 divided by sine 85 equals that times sine 33, 8.2. 8.2, this divide and times sine 33 cancel out, is x. And that is your answer. So feel free to try this question over here. Now, oops, let's do this over here. So we have some sort of triangle, and we want to find the missing angle. All right. So since this is a non-right angle triangle, I can either use the sine rule or the cosine rule. To test for the sine rule, we're going to look for pairs. Well, I have this side angle pair, and I'm looking for this side angle pair. So we have two pairs. So we'll use the sine rule. So let's label it. So let's call this missing angle A. This can be side A. We'll call this angle B, side B, and then C and side C. Let's write down our sine rule. A over sine A equals B over sine B equals C over sine C. In this case, we know pair B, and we're looking for pair A, so we don't need to worry about C. Now, here's something I recommend you to do. Whenever you're using the sine rule to find a missing angle, I recommend you switch the rule. We switch the fractions, okay? So instead of A over sine A, it'll be sine A over A equals sine B over B. So put the angles on top. So when you're looking for a missing angle, angles on top. When you're looking for a missing side, we put the sides on top. So let's fill it out. So sine A, so angle A is x, so we're going to write sine x over A, side A, which is 5.4, equals sine B, so sine, angle B is 95, over side B, which is 6.7. Same again, we want to isolate x. So sine x is being divided by 5.4, so we'll just times by 5.4 to isolate it. Times by 5.4. Times this side by 5.4. That cancels out, so we're left with sine x is equal to sine 95 divided by 6.7 equals something times 5.4, which is going to be 0.802. Oh, let's round it to 0.3. Now, a lot of people say this is our final answer, 0.803. But what you have to do, just like how when you find missing angles in SOHCAHTOA, you must find the inverse of this answer, okay? So sine x equals 0.803. We're going to do the inverse sign, so sine inverse 0.803. And you just put down your calculator. So inverse sine 0.803 which is going to be 53.4. And that's the actual answer, okay? So whenever you're trying to find the missing angle, make sure you do an inverse at the end, okay? And that is your answer. Feel free to do this question below over here. All right, some a bit saucier questions now. Work out the value of x. So I see I have two triangles. I want to find x. All right. Well, let's focus on this triangle here. Do I have... So it's a non-right angle triangle, so I can either use the sine rule or the cosine rule. I use the sine rule if I have two pairs. Well, I'm looking for this pair here, but I actually don't even know its angle. And I don't know any other full pairs. I don't know this full pair, nor do I know this full pair. But maybe I can find the angle, because this triangle adds up to 180 degrees. So 40 plus 65 is 105. 180 minus 105 is 75. All right, there we go. So I'm looking for this pair. Unfortunately, I don't know this pair, nor do I know this full pair here. Maybe I can try and find an extra side. Maybe I can try and find this side here or this side here. So what have I neglected in this whole question so far? I've neglected this triangle here. Well, I see it's a right angle triangle. Whenever you have a right angle triangle, you only have two options. You can either use Pythagoras or trig. Well, so why don't I use, I don't know, let's try Pythagoras first. All right, so I have a right angle triangle. I always like to draw it out separately. I have 13, this is 5. Why don't I try and find this side here? It might help me, it might not help me. All right, so what do I use? I have a right angle triangle, I have two sides, I have a missing side. Well, we can use Pythagoras. So let's label A, B, and C. So the hypotenuse is always C, and A and B don't matter. And Pythagoras is A squared plus B squared equals C squared. So A is x, so x squared, plus B squared, which is 5 squared, is equal to C squared, so 13 squared. Simplify slowly, x squared plus 25 equals 169. We're going to isolate x now. Well, let's just think of the story of x. X is being squared and then added by 25, so we work backwards. So we're going to minus 25. Minus 25, so x squared, that cancels out. 169 minus 25 is 144. How do you get rid of square? You square root both sides. So x is equal to 12. So I know this side is 12. You want to label on your picture. Now, will that help us? Well, I'm trying to find this pair here. Oh, and I know this side angle pair. So we can use the sine rule. So let's label A, B, and C. So this is side A. Let's call this angle A. This is side B. Let's call this is angle B. So A over sine A equals B over sine B. And I'm trying to find the missing side. So yeah, I want the sides on top. So let's fill it out. A is x, so x over sine A, so sine 75, equals B, which is 12, over angle B, so sine 40. So now we have to isolate x. Well, x is being divided by sine 75, so we're going to times by sine 75. Times sine 75 here. That cancels out. So we're left with x is equal to 12 divided by sine 40 times sine 75 is 18.03. And that is your final answer, guys. So, you see a question about non-right angle triangles. If they have two pairs, two side angle pairs, you're going to use the sine rule.